Good day, everyone, and welcome to Learn with Mike. So, for today's topic, it's about combined gas law. Let's start. Combined gas law. The three properties of gas, which are the pressure, volume, and temperature, usually change at once under experimental condition. These are the four possible variations. So, number one, both temperature and pressure cause an increase in volume. Number two, both temperature and pressure cause a decrease in volume. Number three, temperature causes an increase in volume and pressure causes a decrease in volume. And last, temperature causes a decrease in volume and pressure causes an increase in volume. So the three gas laws which we discussed last time, the Boyle's, Charles, and Gay-Lussac's, can be combined and may be expressed into one equation and expressed as what we call combined gas law or the general gas law. Or in short, combined gas law allows us to directly solve for the changes in pressure, volume, or temperature. So combined gas law is the combination of the three quantities, which are the pressure, volume, and temperature, which are present in Boyle's, Charles, and Gay-Lussac's. So this is the formula for combined gas law. P1 V1 over T1 is equal to P2 V2 over T2, where P1 is the initial pressure, P2 is the final pressure, V1 is the initial volume, V2 is the final volume, T1 is the initial temperature, and T2 is the final temperature. And always take note that temperature must be in Kelvin scale. So let's have an example problem. Number 1. A given mass of gas has a volume of 893 milliliter at 33 degrees Celsius and 480 torr. Calculate the volume of the gas at 30 degrees Celsius and 210 torr if pressure and the amount of gas is constant. So, in this case, we write the given. So we have P1, which is 480 torr, P2 is 210 torr, T1 is negative 33 degrees Celsius, T2 is 30 degrees Celsius, V1 is 893 ml. So the unknown here is the final volume. So the first thing that we need to do is to convert temperature scale from Celsius to Kelvin. So for T1, just simply add 273.15. Then the value of T1 is negative 33, so the answer is 240.15. You're going to subtract it because 33 is negative. And for T2, 273.15 plus 30 is 303.15. Now, let's solve the problem. Let's write the formula. Substituting the value, so 480 torr times 893 over 240.15 is equal to 210 torr V2 over 303.15. Then, the next step is to multiply first 480 times 893, so that is 428,640 torr ml. Then copy all the numbers, the remaining numbers. So the next step is to cross multiply. So, in cross multiplying, 210 torr, 240.15K, and V2 is simply, you just need to copy it, and then we multiply 428,640 torr ml to 303.15. So, the answer is 210 times 240.15 is 50,431.5 torr Kelvin, then V2, then the product of 428,640 torr ml, then 303.15 is 129,942,216 torr Kelvin ml. Then to find V2, divide both sides by 50,431, cancel. Then we divide 129,942,216 to 50,431.5. Then V2 is equal to 2,576.61 ml. So the computation for combined gas laws, the numbers are actually, most of the time, bigger numbers. Number 2. Sorry. Okay. The volume of a sample of gas is 750 ml at 60 degrees Celsius and 0.7 atm. At what temperature will the sample 1000 ml occupy under a pressure of 1 atm? So let's write the given. We have P1 is equal to 0.7 atm, P2 is 1 atm, V1 is 750 ml, V2 is 1000 ml, T1 is 60 degrees Celsius. And the unknown is the final temperature. So converting the temperature, which is 60 to Kelvin, so 273.15 plus 60 is equal to 333.15 Kelvin. Writing the formula, substituting the values, 0.7 times 750 over 333.15 is equal to 1 times 1000 ml over T2. Then we multiply some of the values. So 0.7 times 750 is 525 atm ml. Then over 333.15. Then the product of 1 atm times 1000 ml is 1000 atm ml over T2. Then we cross multiply. Copy 525 and T2. Then multiply 1000 atm ml times 333.15. So the answer is 333,150 atm ml Kelvin. Then to find T2, divide both sides by 525. Cancel. Then divide 333,150 over 525. So the temperature is equal to 634.57 Kelvin. Then sample number 3. A 2-liter sample of gas is collected at 20 degrees Celsius and 1.5 atm. What is the pressure of the gas at 300 Kelvin if the volume is 5 liters? Writing the given. So we have V1, 2 liters, V2 is 5 liters, T1 is 20 degrees Celsius, T2 is 300 Kelvin, and P1 is 1.5 atmosphere. And the unknown is the final pressure. So let us convert temperature 1, which is 20, to Kelvin. 273.15 plus 20 is equal to 293.15 Kelvin. For T2, we don't need to convert it because it is already in Kelvin scale. Substituting the values, so we have 1.5 atm times 2 liter over 293.15 Kelvin is equal to P2, 5 liters over 300.15 Kelvin. Multiply some of the values. So 1.5 times 2 is 30. So same, over 293.15. Copy P2 and 5 liter over 300.15. Then we cross multiply. So copy 5 liter 293.15 Kelvin and P2. Then multiply 30 atml to 300.15 Kelvin. So the product is for 5 and 293.15, that is 1,465.75 liter Kelvin, P2. Then for 30 times 300.15, that is 9,004.5 atm liter Kelvin. Then to find P2, divide both sides by 1,465.75. Cancel. Divide 9,004.5 to 1,465.75. Then P2 is equal to 6.14 atmosphere. Okay, so that's all for now. Thanks for watching and I hope you learn. Subscribe if you learn. Thank you.